Hey everybody, ready to take some fun notes? I don't know if I can do this in a crazy voice or not, but I'm pretty sure I can't because I'm just not that talented. But anyway, here we go. Today is the 6th of December, and we're going to do section 6.2, just the first half of the notes today, but that's plenty of notes, especially when I'm not even there to harass you. Apply properties of rational exponents. Basically, first of all, write that, but this next part I put in a thought bubble because I want you to think about it. We've done properties of exponents already. Remember, we took tons of notes on that. That was the stuff you didn't like that much from last chapter. We did things like x to the 5th times x squared equals x to the 7th, because when you have the same base, the exponents just add when you're multiplying them together. We didn't talk about too much with just rational numbers or integers as bases, but 2 to the 5th times 2 squared would be the same thing, just 2 to the 7th power, because exponents would still just add together. Yeah, this part you don't need to write down. And then this last thing in the thought bubble is what we're going to do today. 5 to the 1/2 power times 5 to the 5/2 power. If all we have to do is add the exponents, we have 5 to the 1/2 plus 5/2. Well, 1/2 plus 5/2, well, that's just equal to 6/2. So 5 to the 6/2, which is the same as, well, 6 divided by 2 is 3, so 5 to the 3rd. So the final answer for that would be 125. So that's the type of simplifying we're going to work on today. But first, we must get through our long list of rational properties and do an example with a rational exponent. Ready? First of all, this is all we have to do. Let's do them one at a time now. I know. Okay, the first property, a to the m times a to the n. If you're multiplying two powers together and their bases are equal, you just add the exponents. An example with rational exponents will be like 3 to the 1/2 power times 3 to the 3/2 power. When I add the exponents of 3 to the 1/2 plus 3/2, 1/2 plus 3/2 is 4/2, so that's the same as 3 squared. 3 squared is 9. Okay, so that's the first example. That's a product of powers. Add the exponents. The next one, power of a power, just like we had before, a to the m power to the n power, you multiply the exponents, a to the m times n. So if we had 5 to the 4/3 raised to the 3rd power, we multiply 4/3 times 3. Base stays the same. 4/3 times 3 is the same as 4. 5 to the 4th. 5 times 5 is 25 times 5 is 125 times 5 is 625. Yeah, I know big numbers. Woo. Just kidding. All right, the next one, ab to the m power. Okay, when you take the product of two bases to an exponent, we can distribute that power. So it'd be a to the m times b to the m. So an example of that would be, what if I was taking 25 times 16, all that to the 1/2 power. I could just, instead of multiplying first and then take the square root to get the 1/2 power, I could do 25 to the 1/2 power, which is 25 to the second root of 25, times 16 to the 1/2 power. Well, 25 to the 1/2 power is the same as square root of 25, so that's 5. 16 to the 1/2 power, well, that would be 4. And then 5 times 4 is, anyone? Bueller? 20. Yeah, you're too young to remember that movie. All right, the next one, moving on. A to the negative m. Okay, negative exponents mean move it to the denominator. 1 over a to the positive m. You guys are pretty good at that. Now, my favorite example of that is 25 to the negative 1/2 power. To make the exponent positive, we dump this all in the denominator. So it'd be 1 over 25 to the 1/2 power. Okay, the 1/2 power is a square root, or second root of 25 is 5. Okay, All right. Isn't this exciting? Yes. Yes, it is. All right. Now, the next one, the quotient of powers, if they have the same base, take a to the m divided by a to the n. All you need to do is subtract the exponents. A to the m minus n. Now, here's a very, very exciting example. 7 to the 9/5 divided by 7 to the 4/5. Ew, ugly fractions, but since that's the same base, we can subtract. So we have 7 to the 9/5 minus 4/5. 9/5 minus 4/5 is 5/5. 5/5 is the same as 1. 7 to the first power is just 7. Okay, so that wasn't so bad. And this last one, power of a quotient. Yes, I didn't put the official names here, but we've done these before, just not with fractions. A over b all to the m power is the same as a to the m power over b to the m power. So if I took 8 over 27 to the 1/3 power, punching it in your calculator would make an ugly mess. But if we distribute the the 1/3 power, so 8 to the 1/3 over 27 to the 1/3, the third root of 8 is 2. The third root of 27 is 3. The answer is just 2/3. All right. Now, all of that you should remember from before. Oh, did you see that? I didn't mean to show you that. Okay. The last part of our properties before I'm going to set you loose on some really ugly problems today. The properties of radicals. All right. The product property. The nth root of a times b, that can be written as the nth root of a times the nth root of b. We need an example here of each of these. So an example of this would be a way to simplify the third root of 24. Now there's a perfect cube in 24. 24 can be written as 8. So the cubed root of 8 times the cubed root of 3, because 8 times 3 is 24. So I can separate it like that. Cubed root of 8 is 2. So 2 times the cubed root of 3. Oh no! Sorry. I'm running out of room. Okay, and the last one, the quotient property. To tie this down here. The nth root of a over b, I can separate that into the nth root of a over the nth root of b. Definitely need an example for this, and actually we're going to do 2 examples. You are so lucky. Okay, if I can get this to stay. So the first one is going to be the 4th root of 11 over 16. We can separate this into the 2 radicals, the 4th root of 11, which we can't do, the irrational number, over the 4th root of 16. Well, the 4th root of 16 is 2, because 2 times 2 times 2 times 2 equals 16. So the 4th root of 11 over 2. That's my first example. My second example is one where it's useful going backwards. The 5th root of 64 divided by the 5th root of 2. Since they have the same index, they're both the 5th root, I can combine them into, don't do that, the 5th root of 64 over 2. Now, the 5th root of 64 over 2, 64 divided by 2 is 32. Well, the 5th root of 32, you'll have memorized it by the end of this chapter, or the end of the section. 2 times 2 times 2 times 2 times 2. I think that was 5. 5 2's multiplied together equals 32. So the 5th root of 32 is 2. Okay? So if you need to go back and look at any of this, you can always go on your own and rewind it and check all this out from the thought bubble all the way down. But what you've all been waiting for is the assignment. I know that. So section 6.2, this is day 1 assignment. Oh, let's see, what page is it on? Oh, 424. Huh. Sorry, I like that number. Okay, numbers 3 through 8, you have to do all of them. Oh, sorry, that's not enough. All right, Michael, if you want more problems, I'll do this. Then 15 through 27 odd. Is that enough? All right, so hopefully all goes well. We'll go through the answers to that. I realize tomorrow is Friday. I don't think we'll have a quiz unless you want one. If you want one, just give me a call or text me. Yeah, I know you don't know my text number, but that's why I said that. Okay, hey, I'll talk to you later. This is a really long video. Wow. Okay. Have a good day. Cheerio. How's that for an English accent?